Hey, everybody, welcome back. This is 6.1, part two of our notes. You should have just finished this balloon simulation lab. Okay. Now we are going to talk about why things transfer, how they transfer, and some terms that we need to know. First of all, electrons can be transferred from one object to another. Protons and neutrons are fixed in the nucleus. So when we transfer, we really can't transfer protons. We can only transfer the electrons. There are some terms that we need to know here. Conductors, which conduct electricity through conduction. Insulators, just like insulation in your house, they insulate things and don't allow electrons to transfer or prevent them or slow them down. Semiconductors, okay, are basically like they semi-conduct. They're not perfect, but they're pretty close. Like aluminum. Aluminum will pass electricity, but it's not as good as like a pure metal. And superconductors are really, really good conductors of electricity. So semi, it's like semi-pro and pro, okay, kind of thing. All right. So again, are there materials that electrons can easily flow through? Absolutely. They are called conductors. They allow electrons to move through them easily. The electrons are loosely held in them. This is most metals. The most common are copper and silver. Okay. Are there ones that don't? Well, we already talked about that. Yes. They're called insulators. Insulators don't allow them to move very well. Electrons are tightly held. This is plastic, wood, rubber, and glass. If you've ever looked at a wire, you'll notice most wires aren't just a metal wire. They have some kind of plastic sheath or something over top of them to protect you. Most of your cords, your cell phone cords, everything like that have a plastic, rubbery outer coating to keep you safe. All right. So there are two ways that you can charge things. The first is through conduction. That's charging by contact. All right. I'm gonna show you some demos of this. We're gonna mess around with this in class. Some years we'll do a pithball lab with this. This year we're not going to, but for this upcoming in the future we may. All right. But you literally will touch. You will literally touch something and transfer the charge, and then that will make it a different charge. And I'll show you this in class. Okay. Here are the basically step-by-step ways you can do this so that when you are doing the lab, you can go back and look at this and it will help you. This picture right here is super important, okay? This picture right here has a ground. A ground means basically it goes down into the ground. We suck a charge away. That's what actually happens inside your house. If you go down in your basement or whatever, there's a large metal wire somewhere that allows electricity to go into the ground in case your house gets struck by lightning or something. Again, the other kind is induction, where you do not make contact. It's almost like kind of like if you had to do something to a pet and you like show them a treat and it kind of brings the pet over here and you can remove something off the pet, kind of distract them. You can remove them, you can ground something, and then you walk away, and that pet doesn't even know what has happened to them. Okay, so induction kind of influences things to move to one side, but doesn't actually make contact. Induction influences things to happen. Conduction requires contact. All right, so this is called an electroscope. And what happens with an electroscope is you have a charged area here and you have two leaves at the bottom. And what happens is, as you bring this positive rod towards it, it's going to attract the negative rods, making the ball at the top completely negative. Well, there were positive and negatives in here originally. Okay. And so what happens is if all the negatives come up here, it pushes all the positive down here. Well, when this happens, if these are both positive, these leaves actually move outwards. Okay. So they actually like physically move outwards. They spread. We say the leaves spread out. Okay. So we get this kind of idea. Now, if we would ground this positive stuff, these leaves would fall. All the positive would go down here. And if we took the rod away, then all of this would become negative. And there'd even be a little bit of negative down here now, and it would move out just a little bit, but not as far as it did when it was the positive. Okay? So we will draw some of these up on the board in class. This is a little confusing. I will show you some demos on this, and we will rock and roll with this. And some years we will do the Pithball Lab. If not, I have some demos for you to do. But until next time, Mr. Tima's out.